Now that we've gone through the first few tiniest fractions of a second, we're going to continue on. So the next era of the universe is the era of nucleosynthesis. So nucleo refers to the nucleus, synthesis means making. So this is the time where we're making the nucleus. So at this point, the universe has expanded and cooled off enough that it's now able to begin nuclear fusion. Now, if you remember back previously when we talked about fusion, this is not a cold process. This still happens at very, very high temperatures. So before this point, it was so hot that fusion could not actually occur. I hope that helps give you a sense of exactly how hot it was before this time. So we begin this era of fusion. So this begins at about 2 seconds after the Big Bang and continues until around 10 minutes after the Big Bang. Now, during this time, because we have fusion, one of the byproducts of fusion are neutrinos. And neutrinos do not interact strongly with matter at all, which means that there should still be a background of these neutrinos created during this era of nucleosynthesis. So if we were able to figure out a way of detecting this cosmic neutrino background, we would actually have a glimpse of the universe as it appeared around 10 minutes after the Big Bang. This is still something we're working on trying to figure out. We have recently detected a signal that these things did happen, although it was nothing clear or anything we could use to actually look at what happened in that time period, but we did see evidence that this does exist. So the universe continues to expand and cool, and starting at around 10 minutes after the Big Bang, we then enter into the era of nuclei. So at this point, the largest thing formed in the universe is the nucleus of atoms, predominantly hydrogen and helium nuclei. Now, during this time, the universe itself was so hot that atoms could not yet form. The electrons and nuclei were so energetic they couldn't actually be attracted and bound together through the electromagnetic force, which means the entire universe was filled with a whole bunch of free charges. Okay? And light, being electromagnetic radiation, interacts very, very strongly with particles with electric charge. What this means is that light could not travel on a straight line. It was constantly bouncing around. From our point of view, what this would mean is that the entire universe was actually in a fog. So the reason why you can't see very well in a fog is because light is getting scattered. As it's trying to pass through, it's hitting air molecules, which scatters it out, and so you can only see a short distance, the distance where light is able to actually reach you. So the entire universe was actually filled with a fog during this time. However, the universe continues to expand and cool, and as it does, it finally gets cool enough for the electrons to bind onto the atom, onto the nucleus, forming atoms for the first time. This time where the atoms are combining, this is known as the period of recombination, and it happens at about 380,000 years after the Big Bang. Once this occurs, then light is now able to travel freely, as it does today. So the fog then clears. Okay, what this also means is that the very oldest light that it is possible for us to see comes from the end of the era of nuclei during this period of recombination. So the oldest light it is possible for us to detect is about 380,000 years after the Big Bang. Now, this first light that we actually see and detect, this is the cosmic microwave background. And it actually contains lots and lots of information about not just the early universe, but it will also help us understand how it is that the universe has changed from that time till now. So once we have created atoms, we now enter into the era of atoms. The largest structures in the universe are now individual atoms. Okay, well, the universe is going to continue to expand and cool, which means that we're no longer going to have light. Before this time, the universe itself was actually so hot it was glowing, But after during this era of atoms, it cools off enough, there's no more light just being given off, and we have yet to produce any stars. So because of this is sometimes referred to as the dark ages of the universe, because no light is being created or produced. Now, although no light is being created, there's still some things that we know should be happening during this time. For example, we know that gravity is still acting, pulling things together. So although no light is being formed, we're starting to gather stuff together that are eventually going to form into the first stars and galaxies.